I'm Mike Maloney. I'm a project archaeologist with Stantec.
My name is Darren Kipping, and I'm an underwater archaeologist with Stantec Consulting.
Today we're doing an underwater archaeological assessment of Nassau Mills Dam. So we're looking at historic structures related to the previous dam from the 1800s, and we're using ROVs to get in the water and have a look.
It provides us that opportunity to record how things were built 100 years ago, the construction methods that were used, and preserve a part of Canada's past.
So using an ROV versus using a diver is really a question of safety and efficiency. So if we had divers down, we're very close to a dam, there'd be a lot of safety concerns getting the work done, and also the time that would be required to do it with the divers. Divers would have to come back up, concerns about cold. So with the ROV, we kind of bypass a lot of those things. Normally, if we had divers down, we as the archaeologists would instruct them what to be looking for, what to record, and then they would come back up and kind of inform us what they've seen and show us the imagery. And so we don't have a direct line of communication while the work's actually happening. So it's really useful having the imagery on the surface with the ROV, where we can kind of instruct the ROV pilot where to look, what to do, and go back over certain areas if we need to, rather than have to work through the divers once they come back to the surface.
The experience we're having today with the ROV is fantastic. The few years since we've last used one, it seems the technology and the capability of them has grown extensively, and it's really helping us record these historical remains.
Sonar is really useful for the inspection because we're able to not only identify things if the visibility isn't very good, but sometimes it's easier to pick out linear features in the sonar than in normal camera imagery, because the distortion that you get with the lighting or the color, it's just sometimes it's harder to see things in a camera, whereas archaeologically we're usually looking for submerged stuff. Anything man-made is going to be straight lines, right angles, perfect circles, things that don't really occur naturally. Those things are really easy to pick up on sonar. So through the photogrammetric renderings that we were able to accomplish from the survey, we were able to look at the material itself under the water and actually compare it to the historical documents. And so we were able to correlate the history of impact to the dam over time and actually use the imagery that we collected to confirm the location of a number of items that were in the previous site plans and construction drawings.
For future 3D modeling assessments, the ability and the functionality of the tilt shelf and being able to modify the angles of the additional cameras that we'll be adding will provide better functionality and be able to create a more thorough examination of the structural or the archaeological features that we might be examining. In future assessments, we'll be doing more transects and more kind of detailed survey work.
As far as deliverables to our client are concerned, this ROV is going to increase our ability to create large-scale photogrammetric models of archaeological sites to finish the work faster and more efficiently, and to produce a model that lends itself more to analysis in the future.
The rest of Stantec's environmental services team is really excited by this technology. A lot of our biological, marine biological and ecological teams have showed interest in how they can use this ROV to conduct their surveys and to get better data on their underwater projects.
So in terms of our relationship with the client on this project, we were able to accomplish more than we set out to do using the ROV, and do it in a much quicker timescale and with far less cost than with divers. So it really enhanced our ability to get the work done for Parks Canada.